Virtual memory is a fundamental technique in operating systems that allows for the logical expansion of main memory capacity by using part of secondary storage to temporarily store data and programs. Its main objective is to give processes the illusion of having more memory space than is actually available, thus facilitating the simultaneous execution of multiple programs. This technique also allows only a portion of a process to be in memory at any given time, loading the rest on demand, which optimizes resource usage. Furthermore, virtual memory relies on mechanisms such as address translation and the use of control structures that allow for efficient data access management. Consequently, the implementation of virtual memory is based on techniques such as paging, where processes are divided into blocks that can be loaded non-contiguously, and page replacement strategies, which determine what information should be kept in memory and what can be moved to secondary storage. On the other hand, this approach improves the degree of multiprogramming and system efficiency, although it also introduces some overhead due to the additional management required. Additionally, phenomena such as page faults highlight the need for a proper balance in memory management. Therefore, virtual memory becomes a key tool for optimizing system performance, enabling more flexible, efficient, and scalable process execution in modern computing environments.